Hi, welcome to this lesson on contact and non-contact forces. Pause the video for a moment while you write your date, title and starter down, and then we'll go through your answers. Okay, so starting with a list of all the forces you know, you've probably got gravity. I hope you all got gravity. You might have also got the electrostatic force, that's the force between charged objects. You could have got tension, that's the force in a stretched spring or string. You probably didn't get the normal contact force. Now, the normal contact force is the force that stops any two objects from going into each other. So we'll come back to that quite a lot. You might have got friction and air resistance. You might have got magnetism. Maybe you picked thrust as one of your forces, or upthrust, which is the effect of water pushing upwards on an object. Okay, and the second part was to draw the forces acting on a submarine. So you've got the force of gravity acting downwards on it. Now we call the force of gravity the weight. So we label it as weight on the diagram. And then, as I mentioned earlier, the force of the water pushing upwards is upthrust. Now if our submarine is moving, then we're also going to have thrust in the forward direction, and we're going to have some drag, which is the word used for any force that slows something down in the reverse direction. Okay, so looking at this lesson, our key things are contact and non-contact forces, but we're also going to touch on scalars and vectors, remembering that a scalar has a magnitude and a vector has a magnitude and direction. So forces are vector quantities. They have a magnitude and a direction. Okay, remember magnitude just is a fancy word meaning size. They are represented with arrows drawn to scale. So in this diagram, we've got 600 newtons downwards and 200 newtons upwards. So the downwards arrow is shown with 3 times longer length than the 200 newtons arrow. Okay, so forces can be discussed as a push or a pull. We've got two key types though, contact and non-contact forces. Contact forces require two objects to be physically touching, while non-contact forces do not need the two forces to be touching, although they can be touching. So these three are all non-contact forces: gravitational force, magnetic force, and electrical or electrostatic force. Then our contact forces that we might think of include friction, air resistance, thrust, the normal contact force, the clue's in the name for that one, it's the normal contact force. Remember, that's the force between any two objects that are touching. You might also have tension as a contact force. Okay, so when does 2 plus 2 not equal 4? Well, when we're looking at vectors. Because remember, the direction is important. So let's just take that 2 plus 2 idea. If we've got 2 newtons and 2 newtons and they're both going in the same direction, then yeah, sure, they're going to equal a total of 4 newtons. But if they're not going in the same direction, it's going to be a different number. So if we had 2 newtons and 2 newtons acting in opposite directions, they're going to cancel out completely and give us 0 newtons. If we had 2 newtons acting at right angles to our 2 newtons, then we have to do something a bit more fancy. We have to find the hypotenuse of that right angle triangle. So to do that, we're going to use Pythagoras' theory. Okay, and Pythagoras' theory tells us that the square of the hypotenuse is equal to the square of each of the other two sides added together. So a squared plus b squared equals c squared, where c is the hypotenuse. So in this case, we're going to do 2 squared plus 2 squared to get c squared. Now 2 squared is 4, and 2 squared is 4, so 4 plus 4 is 8. So 8 is equal to c squared, and we need to square root it then to find what the overall is, the hypotenuse. And if I put that into my calculator, that gives me 2.8 newtons. Okay, if we are drawing what we call a free body force diagram, which is a diagram showing the forces of an object, we have to follow several rules. So the arrow has to be in the direction of the force. It should be labelled with the name of the force. The length of the arrow has to represent the size of the force, and you do that to scale using a ruler. And the arrow should come from the point where the force acts. Now what I'd like you to do is pause the video a moment, and I'd like you to draw a free body force diagram showing the forces acting on a person who is standing on the ground. Okay, so here's our person. And we're going to start with the easy force, which is their weight. Their weight is acting downwards from their centre of mass. So we draw a downwards arrow from the centre of mass and label it weight. Now the other force that's acting on them is the force that's stopping them passing into the ground, which is the normal contact force. Okay, so I said that's between any two objects that stop them passing into each other. That's acting upwards, and it's going to be the same size as the weight. Okay, pause the video. Have a go at the grade 5 and 6 questions. You can have a go at the grade 8 as well. That's an extension question. If you don't manage to do it, don't worry about it. Okay, remember the grade 6 question, you will need to use Pythagoras Theory. Right, so for question 5, you could have contact forces: push, pull, reaction, tension. For non-contact, you could have had gravity, the electrostatic force, the magnetic force. Okay, question 6. You should have done 9 squared plus 12 squared to get the square of the hypotenuse. So that's 81 plus 144. Add them together and you get 225. Okay, and then square root that and you will get an answer of 15 newtons. Now, if you had a go at the grade 8 question, what you need to do is you need to use some trigonometry. So we've got our hypotenuse in this case, and we're going to turn it into a right-angled triangle, and we're going to use SOHCAHTOA. Okay, now SOHCAHTOA is linking sine, cosine, and tan with the sides of the triangle. So the 30 newtons on here is our hypotenuse, which is the h. Then we've got the opposite, which is the o, and the adjacent, opposite to the angle and adjacent to the angle. So our opposite is the o. Because we've got o and h, we want to use sine. So sine 60 is equal to the opposite side divided by the hypotenuse, which is 30 in this case. If we rearrange that, we get opposite equals 30 times sine 60. And we put that into our calculator, we get an answer of 25.98 newtons. Then to find the adjacent, we've got the hypotenuse and the adjacent, so that's a and h, which means we're using cosine or ca. So cos of 60 is equal to adjacent over the hypotenuse, which is 30. So again, we rearrange it, we get the adjacent is equal to 30 times cos 60. And that gives us an answer of 15 newtons. Okay, have a go at the work that's been set, and I'll see you next time.